Hopefully I got all the technical difficulties figured out with recording, that it'll all work out for us now. So today we're going to get let's go three concepts today. Okay? First concept is we're going to be converting from radians to degrees and vice versa. So from radians to degrees and degrees to radians. Second concept is with degree measures. Again, they can't make things nice and easy for you. So we're going to teach you another concept about degree measures that makes it easier to give an angle measure to somebody instead of having decimal points. And then the third concept is we're going to go back to the Smarty circles that we had yesterday and tie all three of those parts together that we learned yesterday. Okay? So, first off, most of you probably have been in some kind of a scientific class at some point in time up to this point, because you need 3 credits of science to graduate, and so I'm sure you've all been in at least one science class at some point in time. And science classes, they teach you something called the factor label method. And the factor label method says that if I have 6 feet and I want to convert that into something other than feet, okay, I need to come up with a fraction that's equal to 1. So this blue fraction that I'm producing here is going to be equal to 1, and the feet are going to be on the bottom, and because I'm converting to inches, then inches would be on the top. Well, in 1 foot, there's 12 inches. Okay? And then by doing the factor label method, what you do, or what you have effectively done, is you have effectively crossed out the feet label, because you have it both on top and the bottom. So it's gone, and you're just left with the unit that you want. We're going to utilize the factor label method a ton starting tomorrow. Okay? When we get into circular motion, we're going to use that a ton with pulleys and bikes and different speeds and all that fun stuff. So then once you get it down to only showing the label that you want, in this case is inches, then you just simply do the math. And so in this particular case, that 6 times 12 is 72 inches over, and there's nothing left on the bottom other than just 1. So then we can call that 72 inches. Okay? The reason I show you that is because yesterday we learned that in a circle there is 360 degrees, and that is the same as 2 pi radians. Okay? So what we can do with that then is we can divide both sides by 2, so that we get 180 degrees is just pi radians. And that's going to be the fraction that you use. Now, I can't say you're always going to use the same fraction, because you wouldn't always necessarily use this 12 inches to 1 foot fraction in that order, because if you're given inches, converting it back into feet, then it gets reciprocated. Okay? So, if you are converting 2 degrees, then your fraction is going to be 180 degrees over pi radians. If you're converting 2 radians, then it's pi radians over 180 degrees. That's going to be this blue fraction that you use to convert. So let's convert 90 degrees here into radians. I'm in degrees, so I want the degrees to cancel. So 180 degrees is going to go on the bottom, and pi radians is going to go on the top. However you choose to multiply your fractions, I'm a simplify first, multiply second. You might be a multiply first, simplify second one. Either way, we should get that it is pi over 2 radians at the end. Questions, comments, concerns, clarifications?
Why do you put the 90 by pi?
Because this is like 90 over 1. And when we multiply fractions, we multiply across. Good question. At this time, what I would like you to do is I would like you to convert 315 degrees and 210 degrees into radians, please. I get 7 pi over 4 radians for 315, and I get 7 pi over 6 radians for 210. Yes? Okay. And we definitely like to leave stuff in fraction form whenever we possibly can. Okay. Going back the other way now, so now it's in radians. Just as an FYI, if you for sure see the pi, that's in radians. Okay? 100% assume it's in radians unless you see a degree symbol after it. Okay? If you just see a pi, that's in radians. Otherwise, if you see RAD or if you see that little R, those are all the 3 different ways that we would do radians. Okay? So pi over 6 now is in radians, and so now I want to convert it into degrees. So now 180 degrees is going to go on top, radians is going to go on the bottom, and that's going to give me 180 pi over 6 pi, which reduces down all the way to just 30 degrees. Okay? I'm going to skip to number 3 because then I'm going to have you guys do 2 and 4. If we have 3 radians, we can still convert it into degrees. We would just start with 3 radians, and we would still multiply by 180 degrees over pi radians, and that's going to give us 540 over pi degrees. And I got to put that in parentheses because it's not just 540 degrees divided by pi, it's 540 divided by pi degrees. If we wanted you to decimal approximate that, it would be that. Okay? On a test or a quiz or a formative, we will specifically tell you either exact or rounded to a specific decimal. Okay? 540 over pi degrees is exact. 171.887 is rounded to the thousandths. Okay? So we'll either tell you on a test or a quiz which way we want it. Okay? You now convert 9 pi over 2 and 1 radian into degrees. I want to say it's 57.293. Come on, memory. Oh, nope, 296. So close. Yes? Huh? Love it. So then, that was objective number 1, was converting radians to degrees. Objective number 2 is this funky new concept, okay? So 1 degree is 1/360th of a circle, right? 360 degrees all the way around a circle. So 1 degree is 1/360th of that. Makes sense. Yeah? 1 minute, and that's the symbol for 1 minute, is 1/60th of a degree. That's a bad E.
Like the time?
What? Has nothing to do with time. It's like it mirrors time, okay? But we're still talking an angle. We're talking a part of an angle. Okay? We're not talking like minutes in terms of, since I started talking about this, it's been 1.3 minutes. You know what I mean? We're still talking, it's a part of an angle. Okay? And then 1 second is 1/60th of a minute.
So like time.
But remember, we're talking angles, we're not talking time. Okay? So, in 1 degree, there are 3,600 seconds. In 1 degree, there's 60 minutes. In 1 circle, there's 360 degrees. Okay? The reason I say that is because to give a degree measure, there are 2 different forms that it could take up. The first form is the form that you're used to. It's called decimal degrees. It is literally like it says. It is a degree written out in decimal form. Okay? 171.887 is a decimal degree of that particular angle. Okay? That's a decimal degree. The other form that there is something called degrees, minutes, and seconds. Okay? you need to know how to convert betwixt the two. Okay?
Oh.
Okay? So this is saying 245 degrees, 10 minutes. This part gets locked in. So my answer is going to be 245 point something. That's a bad 5. Looks kind of like a 6. Okay. Then you take this 10 and you have to divide it by 60 to get it into the same part. So now by dividing it by 60, it's in degrees. So that's going to be 0.1666667, and so on and so forth. 10 divided by 60 is 0.16 repeating. Trust me. Okay? So the decimal degree of this is because you converted the degrees, or you kept the degrees, you converted the minutes into that. Okay? Let's try another one. So the 148 is locked in. I'm going to take the 16 and I'm going to divide that by 60. Oops, got the breaks. Not 2s, it's 6s, isn't it? 16 divided by 60, 2, and then 6s, yep. Right? Then I'm going to take the 25 and I'm going to divide it by 3,600. Ask it.
No, why 3,600?
Because we have to all be in degrees, right?
Well, yeah.
Okay? So if I divide a minute by 60, that gives me what it is, what part of a degree it is, right?
Yeah.
If I only divide the 25 by 60, then that's in minutes. I need to be all in degrees so I can add all 3 of those together. Okay? Good question. That's what I wanted you to ask. I get 0.0069. I went 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7.
So the first number, is it the first number that's always locked?
So the degree part is always locked.
Okay.
Yep. Yep, degree is locked in all of the cases.
Is there always going to be a degree?
It would be 0 if it wasn't.
Okay.
Yeah. Mm-hmm. And then I add those 2 together. And so that then gives me my decimal is. Yes, ma'am. Typically, we don't round much more after that, unless we'll tell you otherwise. But okay, going the other way then. So now it's in a decimal degree, and I want to convert it to degrees, minutes, and seconds. So once again, the whole number part gets locked in. So that's 345 degrees. Then what I do is I take the decimal point, so in this case it is 0.12, and now I multiply it by 60. And I get 7.2. So then this part right here becomes my minutes. So it would be 7 minutes. Then I take the decimal part, the 0.2, and I multiply that by 60. Should get 12. Yep. And this is rounded typically is rounded to a whole number. In this case, it just happened to be a whole number. Okay? You now try 215.63 degrees, convert to degrees, minutes, seconds. (215 degrees, 37 minutes, 48 seconds. Agreements? Heads nodding, all abounding. Yeah? All right. Let's go back to yesterday's Smarty Lab. Okay. So yesterday on the Smarty Lab, we were figuring out the relationship between those three variables. R, remember, is our radius. Theta is the measure of our central angle. And S is our arc length. The relationship between those three, I should have used my favorite word, betwixt those three is S is equal to R times theta. The arc length is equal to the radius times the central angle. The kicker, the one caveat, the one condition that has to be is that theta must, you don't get around it, and this will come back to bite you, might even come back to bite you yet today, theta must be in radians. If theta is in degrees, this formula, this relationship, does not hold.
What is that?
Theta?
Yeah. Is that what it looks like?
Yeah.
Just a scribble?
Circle with a line through the middle.
Gotcha.
That's how we name angles.
Just
Typically we use theta first, then we use beta second. Okay? A circle has a radius of 12 centimeters. Well, that tells me right there that radius of 12 centimeters, that's going to be R. Central angle theta intercepts an arc of length 18 centimeters. Well, this is going to be our arc length. That is going to be S. We need to find the radian and the degree measure of theta. We know that S is equal to R times theta. S equals R theta. So if S is 18 and R is 12, we can find theta. How am I going to go about finding theta? Divide both sides by 12. Okay. If I divide both sides by 12, then I get 3/2. But that's what? That's radian. So that's half of my answer was theta. We needed to be in radians. So theta equals 3/2 radians is my first answer. My second answer says I need to convert that into degrees. So if I have 3/2 as my radian measure, I'm going to multiply that by 180 degrees over pi radians. So that's going to give me theta is also equal to 270 over pi degrees. 180 divided by 2 is 90 times 3 is 270. If this were a we would allow you to round type of problem, bad 5. Not picking up, getting lazy on my 5s. $944. Yes?
Just wait.
I can always come back. Try that one. Radius is 8. Central angle is 2.5 radians. So I get the arc length is 20 inches. Agree? Real. Go for that one. Find the length of an arc intercepted by a central angle of 60 degrees. Radius is 9. So I got 9 there. Can I just put 60 degrees in? No, I gotta convert it first. So 60 degrees times pi over 180 degrees gets me here an angle of pi over 3 radians. So then this would become pi over 3. So my arc length would be 3 pi inches, or approximately 9.425. Yes? We got any tracksters in here? Track athletes? No? Okay, let me give you a little breakdown of what a track looks like for those of you that might not know. Okay? A track looks like that. Okay? There are 2 turns in a track. So there's a turn right there, that's a circle. And then there's a turn right down here, that's a circle also. What this is saying is that the radius of lane 1 in turn 1 is 33 meters. It's asking you how much longer the inside of lane 5 is than the inside of lane 1. Okay? Go for it. Try it for a little bit, then I'll do it. Alright.
4 pi.
So if I'm looking at the inside of lane 1 has a 33 meter radius. That means that the arc length on the inside of lane 1 is going to be 33 pi meters. Okay? Because the central angle is 180 degrees, which means the central angle is pi radians. Okay? Then we have lane 1. Then we have lane 2. Then we have lane 3. Then we have lane 4. Then we have lane 5. The inside of lane 5 is the outside of lane 4. So we add 1, 2, 3, and 4 to my 33, and that gives me an arc length of 37 pi meters for the inside of lane 5, which means that there is a difference. It is 4 pi meters longer than the inside of lane 5, is 4 pi meters longer than the inside of lane 1, which would be 12, I believe it's 566 meters longer. Okay. Good times. Good times. I hit the wrong